All right. Hello, everybody. My name is Sean Searslin from the Iowa DOT. Uh, I just want to thank you guys all coming to our second virtual training for BRR on CMPs and reinforced concrete box culverts. Um, the reason we decided to do this as our second training is we have a lot of PCAs with CMPs right now. And so the feds have been very gracious working with us, waiting for us to get BRR set up. So now that we got it set up, we really want to get you guys going on CMPs and getting all these updated and rated for us. And for reinforced concrete box culverts, we were planning to do that as part of the in-person training back in December, but we had to cut our training short due to some weather, so we wanted to make sure that we got that training to you guys. So that's all I'm really going to say. I'll let the Pro Miles people introduce themselves and let them take it away. Thank you.
Thank you. My name is Mark Milnarski, and I work for ProMiles, and I work in the quality control testing and support area of the software.
Good morning. My name is Carolyn Coyce. I'm a technical manager with ProMiles, work on the analysis engine.
And I'm Jeffrey Trees. I am one of the technical leads on the project.
All right, so I think we are ready to get started here. I think we do have a few folks on the call today that may not have been on the last training, so just a couple of quick notes before we get going here. We do have quite a few people on the call, and we definitely want you to ask questions. But if you want to put the questions in the chat, I think that would probably be a good way to do it, and we will try and address any questions that you have. The other quick note, just to revisit, we did send out temporary training licenses. There were a couple of people in the last training that mentioned that they didn't have them, so those should have been sent out yesterday. If anyone is on the call and is not able to access that, please just let us know, message us in the chat, and we will get you set up with a temporary license for training. That license will be active through the end of next week, next Friday, after the third training session. And just one additional reminder that if you do have other licenses for the software that you're using for production work, just make sure to use those, your normal license for your normal production work, since there are some restrictions on the temporary training licenses. So with that said, I think we'll get started here. So the topics that we're going to be covering today, let me share my screen. And I'm sharing a screen here. I'm going to be switching back and forth between a virtual machine here and a couple of other things. So I'll try to make that as smooth as possible, but just bear with me. So the topics we're going to be covering today are the corrugated metal pipe and reinforced concrete box culverts. One thing, let me just share this real quick here. So we will be talking about a few different types of analysis through the training today. So we'll go into all of these things in a little bit more depth as we get through the topics. But we wanted to just take a minute or two here at the outset just to kind of outline the different types of analysis approaches for culverts that are available in the software. So most structure types in AASHTO or BrR are modeled and rated using finite element analysis. So that's either 2D or 3D finite element analysis, where the program will take the input that you've entered and build that model, run the model, and mathematically compute forces, stresses, and then all of that is then used for specification checking and then load rating. Corrugated metal pipe is a little bit of an anomaly within the software, in the sense that it is a little bit of a different approach. It's empirical procedures that basically use AASHTO equations. There were a few states that had developed some like spreadsheet methods for the rating of corrugated metal pipe culverts. Ohio was one. There were a handful of others that developed these methods, and basically they had wanted to get those analysis methods into the BrR software. So AASHTO worked with them to get this incorporated into the software, and we'll be going through in a little bit more detail here. The information that's used for the empirical procedures analysis, um, and then uh, and then also, I guess, just the difference then with the finite element analysis that's used for reinforced concrete box culverts. So that is based on basically a 2D finite element model of the frame of the culvert. The loads and forces are determined, based on the input, and that's then applied to that finite element model. And so, again, we'll be talking about that a little bit more here. And then the third type of analysis, which is not currently available in the software, but we're a good ways through the first phase of getting it in there, so it will be available soon, is soil structure interaction analysis. And that's being introduced into the software through a few different phases. So it may be a little while still before that's fully implemented, but that is in progress right now, where that is like a soil structure interaction analysis for different types of culverts, reinforced concrete or metal culverts. And I think again, just to clarify the sort of three different types of analysis that we'll be sort of referring to at different points here today. If we have a little bit of time towards the end, maybe we can talk a little bit as well about some of the new capabilities that will be introduced with soil structure interaction. But for the structure types that we're covering today with corrugated metal pipe and RC box culvert, we'll be looking at doing the load rating analysis using these two analysis methods here, empirical procedures and finite element analysis for the box culvert. So let me just close this out. All right. So the first one that we're going to be going through today is the corrugated metal pipe culvert. What we're going to do here is we're going to go through kind of an overview of there's an example that was created by Iowa DOT. So I'll be showing you a few things with that. And then we're going to work through the tutorial on how to create one of those culverts. Iowa DOT has created and is in the process of creating a lot of template models for a lot of different structure types. The corrugated pipe culverts are sort of unique structures, so that is an example model rather than a template model. And so we'll work through today here and go through the process of creating one after we take a look at the example here. So the first thing I think to share here, and Sean, if you want to add anything to this, certainly please feel free to. But so the first model that we're going to be kind of covering and discussing here is the Iowa example for the corrugated metal pipe. And so these files are available on the SIMS site here. So yes, right here. So basically we have the templates and examples, and then we also have supporting calculations. So whenever we're working with these models, this is definitely important reference material as well, and we'll be showing that a little bit as we talk about the example model. So you can download those items here. Sean, was there anything that you wanted to add about the information on SIMS here?
I think that mostly covers it. So there's the CMP culvert examples specifically under the one called BrR templates, along with all the other templates we're making. There's also library and system files. The system file or the library files have our Iowa DOT trucks and some rail shapes and some other stuff that not for CMPs, but you might find helpful for other bridges. Um, and the system files, we've already set up some analysis files and things like that with our Iowa DOT trucks. So you may be interested in those as well. So thank you.
All right, great. Thank you, Sean. And we will, in addition, in the third virtual training that we'll be doing next week, we will, the topic for that one will be working with some of these template models. So we will certainly go into more detail on those. So just wanted to show where you can find this information. All right. So once you have downloaded, and I'm not going to show the download just because it's we already got them set up here, but you download those files there, and the couple of things that you'll want to look at is you'll get the
Carolyn, can you maximize your virtual machine and BRDR, please?
yes,
To make it easier to see. Thank you.
yeah. Sorry, just bear with me here. I'm trying to switch through a few things because I gotta pull stuff from my host machine as well. All right, so once you have those files downloaded, you'll have the example corrugated metal pipe culvert. So when you start up BrR, you can, from the Bridge Explorer, you can go to this import button here, and that's how you can import this example culvert. Basically, you would then navigate to the location where you have it saved. Just select it and open it, and it will import that culvert model. Now, as we discussed a little bit in the last training, BrR will not let you save files with the same bridge ID or the same NBI structure ID. So I am just going to rename this since I do already have this in here. And we will go through and show you a few things with this. And maybe I already have a copy number too. Okay. There we go. All right. So we've imported the file here. And you can always get back to that initial window that you see when you do the import by just double clicking right here at the top of the tree. And you'll get back here to this window where you have your structure information and descriptions. A couple things I'll point out here with this window. So these example and template files do have some information here in the description field, which is, again, the first window that you'll see when you import the model. So it's always good to make sure to review this information. This will include just information about the model itself, as well as assumptions that were used in the modeling. So this is always important to review when you're using like the example and template files. Before going further with this, the other thing that I want to just point out here that is kind of an important add-on to this. So we had mentioned there's the supporting calcs files. So this BrR model comes from the XML file that you'll download. The supporting calcs files, we have these PDF files here. And so this basically is a calculation package that is created to go along with this example model. So in this file, you'll see this is the printout of the tabular results from AstroWare showing the controlling ratings and limit states and the analysis that was run for this culvert model. And then you'll see some calculations, assumptions, references, and other information that was used in the creation of this model. These were created for Iowa DOT with their consultants, and this is definitely important reference information when you're working with the example and the template models. So in this file, as you can see, we have the information about the structure that's modeled here. And then let's see. And then we also have here in the calculations page the assumptions that, again, this kind of it goes along with the description field that I just showed you in the analysis model. So when you open up that model and you see this description and assumptions that are outlined here, you can reference these calculations here for some more information about all of that. All right. So one other thing to point out with culverts, and we'll show this when we work through the tutorial for the next one. But you know, this model is already created here. So this bridge workspace view over here in the corner, these checkboxes basically just show you that they sort of allow you to show or hide different structures that will be in this model. So for example, like this model is just the culvert itself. There may be a situation where you want to include, let's say, a culvert and another type of structure within the same bridge model. Like for example, I've seen bridges where you have maybe like a culvert approach span and then some other type of bridge is like a main span, but those are both included under the same structure number. So you may want to have those in the same bridge file. If you want to do that, you can basically check this superstructures. And what that'll do is then it'll basically show the regular superstructure definition in the bridge tree here. And then that's how you can put, like, let's say a girder system and a culvert in the same bridge model if you needed to. We won't really go through the superstructure stuff here much, but I just wanted to point out that if you do have that situation, you can include, you know, those different structure types within here. And then you can get back to that again by going to this bridge definition, and then you can kind of use this to show and hide the different bridge workspace views that you'll see when you're working in the software. All right. So so basically, for kind of a brief overview here, we talked a little bit in the last training about kind of a fairly brief overview of kind of the how to kind of set up a bridge model and how things are organized. Kind of just briefly. Oh, that now everything's gone. Okay, so just briefly, like similarly to how we have for the girder system members, we have this components tab where you define components that are in the bridge, and then you come through here, define kind of the overall layout and geometry of the structure, and then go through kind of the details to these components. So it's sort of a similar approach with culverts, and that defining the bridge alternatives as well. So back to the culvert here, we can see this is kind of a similar setup and layout. So in the components tab, we have the soil properties here. So this is like a standard soil here with the sorry, was there a question or? Okay, sorry, I thought I heard something here. All right, so we have the loads and pressure coefficients, and this again is like library items, so you can copy and save your soil properties. So again, similarly to the library items that we talked about in the last training, you can create these items in the Bridge Explorer, and so if you have something like this that you're going to be using for, a lot of different structure types, that'll be in your library. So when you go to create that model, you'll just double click here on soil, and you'll see this kind of blank one come up. You can either create a new soil type, or you can do copy from library, select a soil type, that you already have saved there. And again, similarly to what we talked about before, you can also then copy these to your library. So for this one, I'm going to copy this soil property to my library. And then if I go back to the library, I see this is now here. And I can then reuse this soil, copy this soil profile to other structures that I will be working with. All right, so we have the soil, and then for the culvert, we also have the steel, the bridge material, the steel. So again, we have the materials library here, and similarly to the other library materials that we've talked about. All right, so for the culvert definition, when you open up kind of the definition for the culvert model, this you'll just see the this is just the culvert definition. There, since there is only one culvert in here in the bridge alternatives, it's just showing the one here. And we will revisit the bridge alternatives here today with the existing and current, but this is just basically showing that this is the culvert that will be included in this model here when you run that analysis. All right, so the dynamic load allowance, you're not really going to be doing anything with that for the culverts, but in the roadway plan view is kind of the next window we have here. And so this shows the layout for this culvert, the length along the reference line, the skew, and the openings. Again, to note, again, for all of these different windows here, we do have the F1 help menu. So as you're working through these windows, or if you're looking at the example models and, you have questions about, let's say, how do some of these numbers kind of, match up with what you're seeing in the example plans? If you want to ever just get a little bit more information about, let's say, the values that are used or exactly what's being asked for in this window, the F1 help menu, just from whatever window you're in the software, you press the F1 help key, and that'll provide you with some more information about what that window is looking for. Okay. Sorry, technical difficulties here. Okay, back in business. All right, so the next window that we have here is the culvert loads window, and so this is basically just showing the soil materials that are used in determining these loads. So this again is set from the components, and then we have the culvert alternative here. So again, we'll be working through creating one of these as an example in just a little bit here. But this is basically just some, information here with the culvert default rating method. Similarly to other structure types, we have the specification version, so it'll default to the current spec edition. But one of the things that people do, use the software for is if you do ever want to evaluate, let's say, changes in the specifications, you can run, once you've got that model set up, you can run that on like the current specification version, or you can run it on previous versions. And that can be, I guess, helpful in kind of evaluating any changes based on specification updates. LRFR factors get set here. And then the control options tab basically just gives you a few different options here on analysis, alternatives, and again, the F1 help window will provide you with some more information. Now, this F1 help includes information about other culvert types here too, but if we go down here, you'll see the control options here for the corrugated metal pipe and metal box culvert.
And Carolyn, we had a question about the CMP portion handling long span CMP arches. Maybe just show where the method of solution manual is in the
Yes.
bridge workspace. I did put a note in the chat and just a brief description. Carolyn had mentioned this at the beginning. The solution for corrugated metal pipes right now is based on an empirical solution that was developed in the spreadsheet that Ohio DOT had created a few years back, and it was also modified by Michigan DOT and Idaho DOT. So the implementation in BrR is a composite. The states all got together and decided, which parts are going to be used, but it's an empirical solution that looks at the conditions at the arch crown.
Yes, thank you, Mark. Yeah, absolutely. So I will show here where you can see the method of solution, and this is definitely an important thing to talk about here. So here we're sort of just getting to the sort of definition of the culvert, but as you're working through this, the way that you can find the method of solution, when you're in this file here, you go to the Bridge Workspace tab, and then you'll see here this engine and engine help. So if you scroll down, you'll see here AASHTO Metal Culvert, LFR, and LRFR. When you click those, you see over here under Engine Help, you'll see the method of solution. If you double click this, it'll open up the PDF with this method of solution document. And this is not a good PDF viewer here. Hold on one second. Okay. Okay. Open the. Sorry. Okay. So that's where you can open this method of solution document. And like Mark said, and like we've kind of touched on a little bit with this sort of empirical method, it is important to, you may run into structures where you're not sure whether that structure would be handled by this. Since it is an empirical method, there are like limits of applicability for these things. And so basically this is a really important reference document to work with when you're load rating these culverts. The references that I think this is definitely important reference document, this and like the AASHTO specifications. I'll show you in a little bit here what you see as far as specification checks and references when we run the analysis. But so this is the method of solution manual. And again, there's method of solutions that are available for all of the different structure types that we have in BrR. The metal culvert one is, again, it's particularly important just because it is an empirical method, and there are limits to the parameters and structure types that are handled here. So when we open up this document, basically this kind of walks through the analysis approach here that's implemented in the software, and provides kind of some more information about limitations and what is considered and how this analysis is performed. We won't go through this whole thing here, but I want to just kind of skim through and note, a few important things. So this does, like we said, since this is not a full, like it's not like a finite element analysis, it's empirical methods. This includes some important information about, how that analysis is set up in terms of loading and the way that, live loads are considered, the way that the load distribution is done. And this kind of goes through and shows you a whole bunch of information about that. Discussing kind of the pressure interaction for different sorts of vehicle configurations, and includes a lot of information here about that. A couple of other things to note here. This does also provide more information about some of the different control options and analysis options. So this is, again, the place that you would go to find more information. Like we said, there's the F1 help menu. We'll provide more information about what that's looking for. This method of solution provides additional information on how that information is used. There's also the summary of the specification checking that's done here, and the AASHTO references where you can take a look at the specifications that are governing that analysis. And then we also have, let's see, where is it here? We also have some flowcharts here. So this I think is helpful as well because this kind of will show you what the software is doing in terms of some of these parameters. And so, in some cases, if you have certain parameters that are for a culvert that's not within this analysis approach, this is a place where you can find some more information about that and what the software handles. And then we also have then flowcharts in here about the specifics on the capacity computations here. So like buckling stress, buckling strength, thrust capacity, seam strength, I think is in here. And then we have, again, like some additional information about how all of this loading is done. So this is a really important reference document here. And again, more information about the analysis methods and the control options. So that's that. And then there's quite a bit of information here. But just to kind of review quickly, reiterate, the place you can find that document is you have to be inside an actual bridge. So you won't find it from here in the Bridge Explorer, but when you're in the Bridge Workspace, you just click this Bridge Workspace tab. It'll take you to this backstage. Come over here and select Metal Culvert, and then you should be able to double click and open up the method of solution.
Yeah, Carolyn, and there was a question about the types of structures that BrR covers. We mentioned that the spreadsheet we are emulating is from ODOT and Michigan.dot. This will do metal arch culverts, and I think if you open up the metal box culvert geometry window, there's a diagram. I think if you open up the example that's included with the sample database, there's I think it's 31, BID 31. So if you open up the metal box, just the geometry. So this is the diagram of the types of culverts that a type of culvert that is supported. So this is the geometry information for that type of culvert. So I'm not sure if that answered the question. Again, these are empirical solutions and they're intended to emulate, what comes out of came out of the ODOT and Michigan DOT spreadsheets. So I'm not sure if that answers the question. And Jim, I think you had some questions on that. I just wanted to see if that was what you were looking for. And again, when Carolyn's done, I'm going to do a brief description if we have enough time about what we're moving towards as far as metal culverts, because it does turn out that the soil structure interaction can be an important part of culvert design and rating. So we'll just give a brief description of where BrR is headed with that. So thanks, Carolyn.
Yeah, for sure. Thank you, Mark. Yeah, so the example that we're looking at today is the corrugated metal pipe. There is like we said here, this metal box sort of arch type. But again, there may be culverts out there that have some type of geometry or something that is more complicated. But the software is set up to handle quite a wide variety of culvert types here. So And then, like we said too, this is also covered in that same method of solution document. So that's where you can find more information about, like, if you have a specific culvert configuration and you're not sure whether it would be like whether this type of analysis would be appropriate. Definitely look through the method of solution, and you can find more information there that'll probably help you make a determination about if what the best way to rate that culvert is, and if this is like an applicable analysis for it. So, all right. So like we said, we kind of set up the culvert here. This basically, so this for the metal pipe, kind of like similar to what we just saw for the metal box. This is where you kind of set the kind of geometry for this culvert here. And then we've got properties for the corrugated metal pipe. There are quite a few properties here that are populated in the library. Um, if you run into a culvert that has some sort of unusual or non-standard properties, you can always create a new set of properties and save that to the library. You can do that within the library window in the Bridge Explorer. Oops. You can go into the library here uh, and click new, and then you can create properties here if you do come across something that is not already included in the library. That being said, there are quite a few common types of corrugated metal pipe that are pre-populated in the library here. And then you can also, you double click this and see, see what's included there. Okay, so that's where we set the properties. And then we have this loads window where you'll set up the information about the depth of fill um, and roadway information, wearing surface. And that basically sets up the culvert model. Now, one thing, again, just to revisit here, once we've gotten through here, we've got the model set up. We can run that analysis model here from within the bridge workspace, but we do still need to have the bridge alternative set up. So in this example model here, you'll see this one is set up, so that when you're running an analysis of this bridge from, let's say, the Bridge Explorer, the correct alternatives will be included in the analysis. And so when we take a look at the other tutorial here, we can again show how to set that up. But basically, you just come in here, double click Bridge Alternatives, and you can go through the process here to create the alternative that'll allow this to be included in batch analysis. All right, so a few things to kind of show here. 1 second. Okay, so once we have this culvert model here, like in this example, I'll show uh, I'll show here, we'll run an analysis and take a look at like the output and stuff. So same with like the other bridge types that we talked about a little bit the other day. You basically select the alternative that you want to run and go to analysis settings. This is where you can select your rating method, as well as, other information about the analysis that you're going to run. These vehicles, again, these are all the library vehicles that we have here. We talked about that a little bit in the first virtual training. There is a library of vehicles that will be imported when you import and set up all of your Iowa DOT system files and library information. We will review that again when we talk about the template models. But for this example, we can go ahead and open up the template and we'll select the Iowa DOT LRFR analysis. And so that then sets up the vehicles that we're going to include here. So that's the analysis settings, and I'll go ahead and click Analyze. We'll see it's real quick for corrugated metal pipe. And so this, we have, like we said, we have the informational messages here. And then we can take a look at the results. So the first thing we'll look at here is the tabular results. And so this is what we kind of looked at here with this should correspond to the information and example calculations, that are provided with this model. So we can kind of review the controlling ratings for this culvert here. And then additionally, we have the spec check detail that you can open up, and this just has the culvert as an analysis point. So we're not seeing different locations on the culvert like we saw with the girders, because this just analyzes the culvert as an empirical analysis just of the culvert. But similar to the other structure types, we can open up these specification spec check articles, and this is where you can review the information about how this is all being computed. So these articles here with like the yellow, these are informational, and these will go through and show the different factors and properties and areas and everything that is used in the rating calculation. And then just, yeah, so, and then references back to articles on this computation. Then here we have, you can go through and see how it's computing the dead load and live load thrust. And, a few other things here. We do have the wheel load distribution as well. So again, there's a lot of information here. If you run an analysis and you're not sure why you're getting the results that you are, there is quite a bit of information here that'll allow you to kind of look through that and see what the software is doing. A lot of times we'll see, if someone goes through and runs a rating analysis and sort of gets a result that seems unexpected. In some cases, it could be, something with the input, maybe something wasn't entered as intended, but other times it may just be that there's something controlling that rating that may not, be obvious. And so this is basically the place to start in terms of taking a look at what the software is doing and why those rating factors are what they are. So you can see here, these yellow ones are like the informational ones. The ones with the check marks are like the actual rating results. And so this, for the rating equation for wall capacity, you'll see that it's going through here and kind of showing where this capacity comes from, and then the rating factors for all of these different vehicles. And again, then here kind of summarizing some of these different things and looking at these rating factors, we can see how this goes into the rating equation. But then we have, thrust capacity, including seam strength. We have these other things here. And so these are values that are computed in these other articles. And so then you can go through and see more information about how those are calculated. All right, let me see. It looks like we might have some questions here. Sorry, I'm just trying to catch up here.
Yeah, we had a question related to variations between LFR and LRFR from Braden. And yeah, I mean, we can't see differences between LFR and LRFR. Um, if you send us your culvert, uh, we could take a quick look at it. Sometimes it can be input related. Sometimes it could be just inherent differences uh, between the culverts. And again, because this is an empirical and not necessarily exact solution, uh, there could be some differences. So I'm assuming this is a culvert that you input uh, with the training, but maybe if you could just send it to us, we could take a quick look at it. And you can, if you want, I'll put the email address um, in the chat. We have a support site, and if you just want to send it there, we could take a quick look at it. The corrugated metal pipe culverts have relatively simple input, so maybe there's just something there that's not obvious.
And Mark, one thing I would like to add too is and Mark, you can add on to this or correct me if I'm misunderstanding something here, but adding the ODOT spreadsheet analysis was a quick and dirty thing that we did to try to get something into the software that people could get ratings. It's even that spreadsheet, it's a very approximate spreadsheet. And you can always check the software by entering the data in that spreadsheet. Now, BRR is probably a little bit different because the states probably did deviate a little bit when we designed the BRR enhancement, but the longer term solution is going to be the SSI enhancement.
That's correct. Yeah,
Yeah.
that's correct, Jeff. Yeah, and this was the SSI enhancement is going to take a longer period of time, so there was a need to have something in there, and states were already using the ODOT spreadsheet. So this was, again, as Jeff said, this was a shorter term solution to be able to look at and rate corrugated metal pipes and arches. Thanks, Jeff.
Thank you guys. Let's see. Yeah, and like we said, so there are in the there are like ash so like we said, these are developed by states. They do reference back to some AASHTO specifications here, so I mean there is information. Now granted, this is all done around design, and so um I guess just um like we said, the states sort of have slightly different approaches then to how this converts over to rating. One reference document that I know has been used and kind of has gone along with some of those spreadsheets is this NCSPA design data sheet 19. So this talks a little bit about um, some of these, how some of the AASHTO design stuff is kind of used for rating. So that's kind of some other sort of supplemental information as well, if you're interested. Um, just just looking here, at this model, I quickly ran LFR and LRFR. The results are slightly different, not, drastically different, but, they are different. And one thing, again, I guess just to sort of go back to is that if you're seeing, if you run the LFR or LRFR analysis, it'll give you output here based on that analysis type that you ran. So, um, so in this case, before I had run the LRFR analysis here, I ran the LFR analysis. And so the spec check detail here does update to reflect the type of analysis that you run. So the rating factors that are shown here, I mean, it should reflect the analysis that you ran. So you can find, more information about what it's doing if you take a look through that spec check. So, if you're ever, I guess, questioning if what the software is doing is correct, that's a really good place to start and allow you to review the values that are used in the analysis that's being run. Let's see. Okay, so I think with that, we've kind of mostly covered sort of the overview here of this example model. So um, so again, this was created. Iowa DOT has created these models for people to kind of use and work with. Um, so this one you can find on the SIMS site, along with the supporting documentation. Um, so let's see. I guess if there are any other questions about this model, or I don't know if Iowa, DOT wants to add anything about the example model here. But yeah, I guess if we have any questions or comments or anything before we move on and look at the CMP tutorial culvert.
I don't have anything to add, so thank you.
Okay.
And I think we're caught up on questions for right now. So yeah, go ahead. You can
Okay,
move on,
great.
Carolyn.
Great, thank you. Yeah, I'm trying to kind of keep an eye on the questions, but multitasking a little bit here. So I just wanted to make sure I'm not missing anything. So thank you.
You're welcome.
All right. So no. All right. So the next thing that we are going to discuss here is so for the training, there were a couple of tutorials that were sent out, that we're going to be kind of discussing here in the training. This first one here is the um, corrugated metal pipe example tutorial. So I don't know if many of you have had a chance to take a look at the tutorial or work through it. For the sake of time, we're not going to, I guess, work through the entire examples here, but we will go through and make sure to kind of show you how to set these up. If you have not had a chance to take a look at this yet, please feel free to kind of start to work through it, and we would be glad to answer any questions that you might have about it. All right, so the tutorials here that were sent out, basically these kind of walk through a step-by-step explanation on how to create the models and the process here. So for this one here, we start out with just some information about the corrugated metal pipe that we're modeling. And then we'll kind of go through and I'll just show here setting this up and kind of creating a new culvert. So the model that we just looked at was an example model that's already been set up. But since that's an example rather than a template, when you are creating a culvert model, you'll be kind of starting and creating a new model. So we'll just walk through here and show a little bit about kind of how we do this. So we'll start out here in the Bridge Explorer. So again, this is what you'll see when you open up the software. And to create a new bridge, we'll just go here and click new, and we see the bridge, the new bridge here, like the same window as we saw for the one that we imported. So again, if you do have the training version of the software and you want to kind of follow along here and work through this, I will just kind of briefly show a few steps here on how we get this created. All right, so this is basically just setting up the bridge description. And again, you will want to, as you're kind of setting up these new culverts, I would really strongly recommend, taking a look at the reference document here for the Iowa DOT example culvert, to try and make sure that anything that's kind of specific to these culverts that you have this information that you can reference as well as far as how these are set up. And then again, for the bridge workspace view here, we'll turn off superstructures and substructures since we're just working with culvert here. So this created the bridge, and so to start out, we can go to create a culvert definition, and we'll do corrugated metal pipe culvert. So that creates the culvert definition here. Again, the impact is not modifiable for culverts, so we don't need to do anything there. And so the next thing we do is set up the roadway plan view. So for this culvert, we're going to do a 0 skew and a 90-degree opening rotation. Oops. And the culvert length of 50 feet. All right, so then we are going to come in and set the soil profile. Now you'll notice that I did not in this bridge model set anything up for components yet. I didn't go through and add anything in here. You can add things through here as well. So if I go to soil material and create new material, it'll open back up this same window here. And so then I can go ahead and get the soil material here from the library. I'm going to use standard soil 1 for this example. So then that gets set to the bridge. I click OK. Now this is, again, basically kind of the same thing as if I had set it up in the components tab. So this now copied that soil material to this structure. So we see here now, there's this copy of it over in components. Again, just to touch back on this, the library items that we're using here, when you get an item from the library, it copies that item to the bridge rather than like saving it or borrowing it. So if you do go back into your library and make any changes to that, the version of it that was copied to the bridge will remain in that bridge file. So this soil is going to stay the same in this bridge unless I change it in the bridge. So got that set up. All right, so then we can go ahead and create the culvert alternative. And we're going to do metal pipe for this example. And so we'll set up the corrugated metal pipe. Set any properties here. Sorry. 95. And I don't think we need to make any changes here. System factors and control options. And so for this example, we will go ahead and select these control options. All right, so once we set up that alternative, we can now expand this. So it's the alternative we just created. So here's where we can come in and enter the geometry for this culvert. So we'll look at the span length and rise. And again, the F1 help window can provide a little more information about about some of the information here, the input that the software is looking for. We have the span, the rise, and the rise above the haunch. So then we come through and set up the metal culvert properties. Again, we can we can set the material here just by clicking create new material, or you can set it up in components. Either way, we'll save that material to this bridge. So we'll go to the library again here. We're going to go with the steel corrugated structural plate and click OK. And so that then saves a copy of this steel material to the bridge. Then here for section properties, you can either directly enter properties or copy from library.
And
So for
just
this,
with regards to that, there's a standard library that's delivered with the software, but you can also add uh, your own corrugated shapes if you have them.
yes, yes, exactly. Yeah, the ones that are in the library cover a lot of common ones, but there certainly may be some that you come across that aren't in there. So you can add them just for that bridge, or if it's something that you come across a lot, you can save it to the library so that you can then reuse it. All right, and so then we can do conditions. So crown deflection, adjustment factors. All right. So then the last window here where we need to define information, we have the depth of fill and minimum cover. Then water height and roadway width. And then wearing surface. All right. So once we've got to this point, we have set up the culvert and it can be analyzed here. So we'll go ahead and run that analysis in just a second. But we do need to create a bridge alternative. And I'm not sure if this is included in the tutorial, but we do need to create this bridge alternative here. And again, the reason for this is to let the software know what the kind of existing current version is for different things that might be modeled in the same bridge file. And again, this can be a little counterintuitive from the standpoint of rating engineers, but from the perspective of structure owners, we've heard from a lot of states that it's really valuable to have this ability with bridge alternatives to be able to keep different, I guess, files for that bridge in the same model, as well as to like evaluate changes over the lifespan of the structure. And and I think I did this. Culvert. Okay. All right, so there we go. So we set up the culvert alternative. Reference line here. And so then this is showing that now we're saying culvert alternative 1. This is our existing and current culvert. And then this is the culvert definition that's saved to that alternative. So again, if you do have multiple culverts in here, this is where you save them to those alternatives. Okay, so we got this set up, and then we can go ahead and run an analysis. So we'll do an LRFR analysis, and for this example, we'll just do HS20. Analyze. So then in the tabular results, we can switch here to the single rating level, and then we can see the rating factors and controlling limit states that for this culvert. So again, tabular results, kind of first place to look as far as your rating results, plastic moment, and then we can go to spec check detail to get more information here about this this rating analysis. So we see here under tabular results, the inventory rating factor 0.918 is less than 1 here. And so that's why in the spec check, we have this red X here. So this is basically just saying that this rating factor is less than 1. Now for an inventory rating, it's an assessment. It is what it is. But when you're running the full set of vehicles, if you have a permit load or a legal load or something like that, and you get the ratings below 1 or get that red X, that's when you would look at, restricting the structure. So going in here into the spec articles here, we can see for plastic moment, we have the information here about the capacities that are determined based on what we've entered. And then we can also review these other articles here that show kind of how it gets there. So again, like we looked at with the last example, we've got information about how the dead load and live load thrusts are computed, as well as resistances and geometry. Let's see. Oh, another thing to point out here too. So when we do run these analysis, you will sometimes see some information, warnings, occasionally maybe some errors, but you'll see some information here. And so, this can be good to review. This relates again to the way that the loads are modeled here for the empirical loading. And anytime you see anything like this, if you have any questions about it, you can always just reference the method of solution, and just make sure that you understand, how the structure is analyzing that particular culvert. Let's see what else to cover with this one. The other thing to note too, we did mention that some different structure types, you'll be able to find some other additional information in the engine outputs. Corrugated metal pipe, there's probably not a whole lot you need to look at here. This is just a log file. When we look at reinforced concrete box culvert in just a few minutes here, we'll see that for that one, we will have a lot of things in the engine outputs that we'll want to review. But so for corrugated metal pipe, Really the main places that you're going to find your information is tabular results and then the spec check detail. Um, and then and then again, I guess the important things to keep in mind as far as references when you're working on these, method of solution, when you're in a bridge model, bridge workspace, engine help, select the one you want and double click to open the method of solution. So, and then also reference the documentation that Iowa DOT has put together regarding the example files and models. Um, all right, so I think that covers most of what we were going to talk about here with corrugated metal pipe culverts. I guess before we move on to reinforced box culverts, were there any questions or anything else that anyone wanted to discuss here with CMP?
Okay, I don't see anything. So, Carolyn, if you want to go ahead and get started with the reinforced concrete. Um, and just while Carolyn's starting that up, just kind of as a reminder, if you have any questions after this is over, please feel free to forward those to Sean, or you could also email one of us. But uh, or even as we get started on the reinforced concrete, if you still have a question on the CMP, let us know. And as I mentioned, if we have some time at the end, we'll just go over, what's coming with the corrugated metal pipe and the soil structure interaction. So, all right, Carolyn, go ahead.
All right, great. Thank you, Mark. Um, all right, so there's a few different things that I think we'll kind of talk about here a little bit with the reinforced concrete culvert. And one of the first things I think we're going to look at a little bit here is the method of solution. But before we get into that, just so that you see, this is the culvert tutorial that we're referencing here. So this was sent out along with the training information. You can also find additional tutorials on the Ashtaware website if there are other, like, if you're looking for maybe another example or something like that. We can put that up here just so you see as well. Okay, the Ashtaware BRDR.org, and then training. You can find some additional tutorials and examples here. If you have a structure that maybe is a little different and you want to try and find something that might be an example on how you can model that. Sorry, let's close that out. Sorry, bear with me one second. I've got a lot of documents open here that I'm trying to keep track of. Okay, here we go. Okay. So this is the culvert example here, some information about the culvert. Before we get into this, just again to kind of talk a little bit about the differences in the analysis approach for reinforced concrete versus corrugated metal pipe. So, like we said before, the corrugated metal pipe is an empirical analysis. Reinforced concrete box culvert is more similar to how we do other structure types in BrR, where we'll generate a finite element model based on the information that you enter, and run that model and get forces and stresses from there, and then do spec checking and rating from there. So similarly to the corrugated metal pipe culvert, we can find the method of solution for the reinforced concrete box culvert here. The metal pipe one is the one that's AASHTO metal culvert. The reinforced concrete box is just the AASHTO culvert here. So we can select that and go to method of solution. And this will open the culvert method of solution. A few things I won't go through everything in here. There's quite a bit of information, but there are a few things that I want to kind of highlight. So again, you can get to this document by when you're in any bridge, just open any type of bridge. It doesn't have to be a culvert, any type of bridge, and then click the bridge workspace, select the structure type, and then open the method of solution from there. All right, so the culvert method of solution manual, this kind of will go through, and we're just gonna again kind of skim through this and point out a few things just to sort of highlight what the analysis process is for this, and kind of the differences between this and the one that we just talked about here. So the method of solution document kind of will go through, and this it's good to skim over. It'll provide kind of an explanation of how the model is generated, as well as some kind of important information about basically the way that the finite model gets built. And as we'll see once we run the analysis and look at the outputs, it'll be kind of helpful to understand this in terms of just a frame of reference for, which elements are being referred to and just kind of how that model is set up. All right. So again, this kind of will just go through and show how this is, how the model is laid out and how the different nodes and elements are set up. Again, this is, it's a finite element analysis similar to like the girder models and stuff, but since this is a frame structure, the geometry here, we got to, pay a little more attention to how these nodes and elements are getting set up to be able to understand some of the results. So like we said, when we go through and enter the information that we'll talk about in just a minute here, we'll see a few things here about support constraints and parameters that we can set for the model. So again, the software will generate the finite element model here based on the information geometry for the structure, and then we'll set support conditions, and basically and loads and supports here, that'll basically set up that model. Some options here on moment continuity and bottom slab. And then basically we have the reinforcement. Again, we'll go through this in the software just in a moment here, but I just want to kind of point out the information that's available here that I think is helpful and really kind of necessary sometimes when you're analyzing these culverts. There are a lot of times where you'll run into something and it's important to make sure that you understand what the reference point is that the software is asking for some of these inputs, to ensure that you're getting the structure modeled the way that you intend to. So again, just skimming through here, right? So once it builds the finite element model, it'll basically compute vertical and horizontal like earth loads and forces based on the information that's entered, and then apply those to the finite element model. And then it will also compute live load surcharges and pressures for the vehicles that are included in the analysis. Static water pressure, and then so the live load surcharge again relating to the vehicle, at the near the structure, the pressures that come from that. But then there's also the live load distribution on the top of the structure, which is computed in accordance with AASHTO, based on the depth of fill, and so this kind of goes through and shows how those loads are computed and distributed. So again, if you set up a model and you get an analysis result that you're not expecting, this can definitely provide a lot of information about what the software is doing, and so you can ensure that it's doing what you intend to. And then again, the specification checks that are included in the rating analysis. And then similarly to the other structure types that we've discussed, the corrugated metal pipe and other structure types within the software, the method of solution also includes some flow charts kind of working through and showing how the software will treat different scenarios and configurations that are entered for the purposes of parameters for like load distribution and specification checking. And then again, the impact and fill depth and all that is in accordance with AASHTO. And so, and then there's some additional information here about like service loads and punching shear and all that kind of stuff. This also provides information that is going to be helpful in some of the output that we'll look at in just a few minutes here. So just want to take a few minutes to kind of go through this just because there is a lot of information here. And, a lot of times we get questions about, why is this I ran this model, I'm getting a result that I'm not expecting. And so, there is a lot of information here that can kind of help you assess what the model is doing. So with that being said, quick overview with what we have here in method of solution. We'll take a look here at this culvert example tutorial. Okay, so for the reinforced concrete box culvert tutorial, Um, these can take a little bit more time to enter just because you have a lot of different reinforcement bar definitions that you have to create. So for the corrugated metal pipe, I went through and showed all of the input for this one. We'll show the input and we'll talk about it, and then I'll just kind of show some examples on how you create these, and we'll also kind of touch on a few important things here as we walk through it. So like I said, we do encourage you to work through this tutorial. Just for the sake of time today, though, we're going to go through and basically kind of show how to do it. And we'll go through all the windows and all the steps here. But I do have it pulled up here, one that's created so that we can go through it in a way that'll fit into the time that we have here today. So, sorry, 1 second. Okay. So for this example, and sorry, I'm switching between a virtual machine and my main machine here. So again, apologize if anything here is hard to see. Um, but so for this tutorial, basically it starts out with some information showing the structure that we're going to be modeling. So we have our 2-cell concrete box culvert and the reinforcement bar information. So again, information you'll get from your bridge plans. And so to create this model, we'll do similar to what we've done for these other structures. You'll start here, click new bridge, and enter the structure information here. Again, you want to make sure this culverts is checked, otherwise you won't see the culvert definition available there. I'm going to show the one that we have modeled here. So I said we'll start out with new bridge, and then that first window that we see is this bridge definition window. So again, we'll set up our bridge description information. We'll make sure that culverts is checked here so that we can see it. And so then we've got that set up here. All right. So for the concrete culvert, and like you would with a lot of bridge types, The software is sort of one thing about this software is that it is sort of set up to, in a lot of cases, try and make it easy to input information in a way that's like kind of typically shown in bridge plans. There are things that sometimes you'll have to like, adjust, compute, make sure that it is a dimension referencing the right point or whatnot. But kind of similarly to how you would think about even just like setting up, a calculation package if you're not using a software. One of the things you'll do is kind of come in and like define, like components and material properties. Um, so, so for this structure, we've got the concrete, reinforcing steel, and the soil. So similarly to the other structures that we've looked at, to add the concrete here, we'll just double click on concrete. You can copy from the library, choose the concrete that we want to add here. We can click OK. Again, you can always, let's say you want to use a different concrete strength. Once we've copied this from the library, this is now a copy of that library item. So it won't change the library item if we change it in here in the bridge workspace. And so I want to say, and again, this is not exactly in this tutorial, but just to kind of show, just because this is something that is frequently used. So let's say I wanted to bring in a 5 KSI concrete. Again, this is a copy of the library item, so I'm not changing the library item itself. So I can change the compressive strength, click compute, it'll recompute my modulus of elasticity, modulus of rupture. I can click OK to save that to the bridge model if I want to. So I've got this one, which is the 3.5 KSI concrete that we're using for this culvert example. We've got this 5 KSI one that I just entered. Again, both of these materials are saved just to this bridge. So we copy them out of the library into the bridge and then can modify them as we want to from there. So that's just to sort of show creating it, but we're going to delete that because we won't be using that one in this model. So we've got the 3.5 KSI concrete that we'll be using here. And then same thing for reinforcing steel. We'll do 60 KSI rebar, so we can double click here and we can either enter the properties directly or we can copy from the library. Get grade 60. When you're in here, you can double click, see the properties that it's going to enter. Click OK. And this, again, will save it to my structure here. And then soil properties as well, kind of like we did for metal culvert. You can create, double click to create a new soil property and enter the properties that you want to use. Or you can double click and do copy from library and use a soil that you already have saved. So for this example, we are using this standard soil here. So that covers the bridge components that we'll be using here. And we can see that they're available in the bridge. So we can go ahead and the next thing you'll do then is to create that culvert definition. So again, I did set this model up so that we could kind of look at it here, but to create the culvert definition, you just double click culvert definitions and enter your information here, culvert definition 1. At this point here, when I'm creating a new culvert definition that I haven't created an alternative for, you won't see alternatives there. I'll just do that as an example. Okay, so I'm making a new culvert definition here. So now we can see we have these two. And here, since I haven't created the alternative yet, we don't see anything here for existing and current. When you go through and create the alternative, you see box. Once this alternative is created, then if we go back to this culvert definition, then we'll see that this now has a culvert alternative associated with it. So this is the culvert alternative that is the existing and current alternative for this culvert definition. So that's just kind of an example. So I'm going to delete this one. But we'll see the same thing here with this culvert definition. So we have culvert definition 1 here and culvert alternative 1. Now for this example, we're just going to be working with this culvert alternative 1 for the analysis. There is a culvert design tool in the software as well. We're not going to be covering that today, but that's what that is relating to. Actually, just for the sake of not, okay. All right. So when we create the culvert alternative, after we select RC box, this is the window that'll pop up with the culvert alternative description. This is basically where you can set some information about your culvert and soils, earth pressure. And again, like the other structure types we've looked at, this is where you can change the spec version that's going to be used for spec checking for the culvert. Again, we're defaulting to current specs, but you can change that if you'd like to. Then we have our LRFR factors and control options. And so in the control options, again, here you'll see some things about where points of interest are generated. Like for corrugated metal pipe, it's basically just like a single analysis since it's the empirical analysis. But since this is a finite element model, this is where it basically tells the software kind of where to generate analysis points within that finite element model. You also have some options on shear computation methods, the option to exclude the bottom slab if you have like a three-sided culvert, and a few other options here that kind of correspond to different analysis methods within AASHTO. That's where you can set your control options. And again, that's in this culvert alternative. All right. So default materials just shows the materials that we've already defined here, but the next step in creating the culvert will be to go to the RC box culvert geometry. And this is where we'll enter the overall kind of configuration of the culvert. Again, here where we have width, like this is inside width, and we have another wall here or another window here where we'll enter wall thickness information, and the software will take that information and kind of put it together to build the finite element model. Again, this is the F1 help menu. So I just, from within this window, just click the F1 help, and again, you'll see some more information here about kind of what it's looking for a little bit more precisely. Sometimes just within this window itself, you may have questions about how different things are measured, or what dimension is it looking for exactly. And so the F1 help menu here can be helpful in verifying that you've got the correct reference points for those dimensions.
Yeah, and just a note on this one, I think it says it at the top. This is a 2-cell culvert, but BrR will support up to a 10-cell culvert. I don't know that I've ever seen a 10-cell culvert, but it'll do single boxes, double boxes, triple boxes. But this is where you would define that. And also, this one does not have haunches, but it also supports corner haunches as well.
Yes, thank you, Mark. Yeah, exactly. There are quite a few different options on that configuration here. Like you said, cells, bottom slab present. So if you had a three-sided structure, or if you wanted to analyze it, different ways of analyzing things, and then again, the haunches then can be entered here as well. Okay. All right. So then the next thing we have here for input is this end conditions window. So for this example, there isn't really anything that we need to enter here, but this refers back this that we kind of touched on a little bit when we were looking at the method of solution in terms of some different modeling options. I'm just looking at something here. Okay, so here we've got options for moment releases at the top and bottom of the walls. Again, if you determine that it's appropriate to analyze the culvert that way, this end conditions window is where you can set those. And then sideway support. So again, when we have things like this, we can reference the F1 help, and this will talk a little bit more about kind of how the moment releases are applied or set in the finite element model, as well as kind of the support conditions that are used here with like sideway support and the spring support subgrade modulus. So we have that information here in the F1 help. And then we also, where is it? We also have here in the method of solution some additional information about how this information gets used in building the finite element model. So again, for this example, we don't need to make any changes here, but this is just good to be aware of for some of the types of culverts you may be trying to model. Sorry. Sorry, 1 second. All right. So basically, kind of working through this example, we've gotten here to through the box culvert geometry. And then just to go back to the tutorial for a second here, the next thing that we're going to do is set up these bar mark definitions. I want to just show the tutorial here for a second before we look at this in the window. And this is kind of what we're referencing in terms of trying to make things kind of easy to enter from bridge plans. Here we have all of these different kinds of bar definitions, but a lot of times in your culvert plans, you'll see this like bill of bars here. And then you'll have your bent bar shapes and dimensions and all that. And then you have, they'll typically be associated with a bar mark. So that's how a lot of people will set these up, is they'll, refer to those plans and then just create the bars that are used here in the culvert. And then in a couple minutes, so after we kind of create all of these bars, then in a couple minutes here, we'll show you how you actually assign those and position them within the culvert. So the first step here is just going to be to create those different bar mark definitions. So you do that here within this bar mark definitions window. So if you double click, this is the window that you'll see open up here. And so basically you name it, you can name it according to your actual bar mark, select your grade, size, and then the different kind of configurations of bars here will determine the dimensions that you'll need to populate. One thing to mention, probably kind of an uncommon situation. So in 7.5, for this bent bar is a 1-to-1 slope, and so you have this H dimension. In 7.6, one of the user requests included adding some more things with bent bars. So in 7.5, you can define these bent bars. They have the 1-to-1 slope on the bend, and they can be applied. We'll show this later, but they can be applied for like negative moments. So they'll bend, let's say, over or under a wall, typically. And so that's what's available in 7.5 and previous. In 7.6, bent bars can also be used for like positive moment, and you can also enter a slope here that's not 1-to-1. So I can kind of briefly, that may make a little more sense when we see later kind of where the bars get assigned, but I just wanted to mention that. Again, it's probably kind of uncommon, that you would need that, but it is available in the event that you do.
Yeah,
Um,
and one note on that, because I think Carolyn's going to show the schematic. There was a bug or a something that didn't work in 7.5 as far as viewing the schematic. The bent bar was not the slope of the bent bar was not shown, and that's been updated for 7.6, so we actually show the slope. So even though if you're looking at your schematic, and I think this is the case in 7.5, but if you don't see the slope, it is there. It's just it's not shown in the schematic.
yes, that's correct. Thank you for mentioning that, Mark. I I don't know. Does this example have bent bars? I don't think that this example includes bent bars.
It may not, but it's not uncommon for you to have those bent bars. So if you see it, if you put a bent bar in and you don't see the slope, um, you'll just basically just see the straight line. So if you're using 751, you may not see it.
Right, correct. Yeah, but the program will still analyze it. It's just it doesn't show the bend in the schematic. It'll show the straight part, like you said. And it does have the references here as well. So you can always double check then as far as the different ones that it's referencing. So yeah, so I think this example does only have straight bars, but yeah, thank you for mentioning that, Mark. In 7.6, there are some additional options that you can do with bent bars, as well as the schematic is fixed up to show them more clearly. All right. So, so you won't see that schematic yet. In the modeling process, we've got a few steps here, and so that won't populate until we actually assign the reinforcement in this window here as well. So if you are kind of working and following along, that won't be available until we actually assign these bars to their locations here. But so back in the bar mark definitions, we'll create these different bars again from that bill of reinforcement from the design plans, and go through and create all those here. And again, for the sake of time, I'm not going to go through and create them all individually, but this we've got them set up here in this model so that you can see what the end result looks like. And in the tutorial that was provided, it does walk through step by step for each of them. So again, if you are working through this tutorial, which we would encourage you to, it does show here the different references and the creation of each of these different bar types. So that's shown step by step in the tutorial. All right. So, so we've got the bar mark definitions set up now for all of the reinforcement that we're gonna use in this culvert. And then the next thing you would do is create a culvert segment. So you double click culvert segments, and this will allow you to create a new one. And this is where you would enter, the names and lengths and stuff here. So this is the one that we've got created here for this example. So we'll enter culvert segment 1, the concrete material that we're going to use, and the length of the culvert segment. Now for this culvert segment, this is where we define the thickness of the walls and slabs, as well as then the loads, and then assign the reinforcement to that concrete or to the culvert here. So this window, the thickness, we have the cell top and bottom slab as well as the walls. And so this field is going to be populated based on like the number of cells that you've entered for that culvert. Sorry, not here. Here. So in RC box Culver geometry, so the number of cells that you enter here is going to determine the way that this window is populated here. So this will match up with that. Again, F1 help here will provide a little more information as well. So we've got that. Then this next window here is where we set up the loading on the culvert. So we have some diagrams here that'll sort of show some of the reference distances that it's asking for as far as these dimensions here. So the depth of fill at the start and end, wearing surface. Again, wearing surfaces you can save to the library. We don't have one for this example, but you can save that to the library as well. And then the live load surcharge height for LRFD and LRFR. Again, F1 help menu here shows, again, some little more information. And then we have the live load distribution factor. So again, the distribution factor is determined in accordance with AASHTO, and so it's based on kind of the distribution width or length based on that depth of fill for the culvert. So this is basically the kind of like the slope of the distribution width that's then used to compute the pressure based on, again, the depth of fill for that culvert. 1 second here. So back to the method of solution, you have like the length, contact area length, and then we'll look at like basically the slope of distribution to determine the pressure on the culvert. So more information here if you ever want to just double check exactly what it's looking for there. All right, and then we have options here for soil pressure, and from there we've got all of our culvert loads defined. Okay, so the last kind of main step here is going to be to set up and assign the culvert reinforcement. Again, you can right click here to see the schematic of the culvert, as well as like the call outs to the different bar mark definitions that as they get put in place. So again, in 7.5 and earlier, it doesn't show the bends on the bend bars, but it does show all of your bars and references to them. So this is, I think, helpful in terms of just making sure that things are kind of positioned properly. So the way that you assign these bar locations is in this box culvert reinforcement window here. So there are different tabs here for top slab, top and bottom, bottom slab, top and bottom, corner wall, and dowel bars. So like for these top slab top bars, these are bars that we'll use for like negative moment here over the walls and stuff. You can, click new, select the bar mark definition that you want, cover, spacing, and then the way that you position that bar, you have a few different options here. So you can reference, and this is really just to try and allow people to enter it in whatever dimension might be kind of most easily shown on the plan. So measured from the center of the wall or center of the culvert. Or you can just say, centered. And then these will populate here with start distance and length to just try and help you ensure that like this is referencing from the right place. And again, you should then, once you click apply here, you'll see that bar show up in the schematic, so you can kind of try and visually verify as well that it's positioned the way that you want it to. So again, as you're working your way through here, like let's say you just do this tab first and get these entered, even though you still have more work to do in this window with the other tabs, once you click apply, the bars that you've entered here should show up in the schematic. So just helpful in terms of just trying to verify correct placement. We also have the checkboxes here for fully developed at start and end. If those are unchecked like they are here, the program will compute the development length of that reinforcement and then use the appropriate sort of adjustment to that reinforcement over the development length. If you do check these, then it'll just consider them to be fully developed and it won't do reductions based on development length. All right, so like we said, this part can take a little bit of time to set these up, so we're not going to go through each of these individually. The tutorial does show, setting up each of these bars, but for the sake of time, and we won't go through each one of them individually, but this is basically where you would assign all the reinforcement definitions that we've created. And then we should be able to, again, verify in the schematic. There is this points of interest here. There's not a whole lot of options on culverts, but you can change shear computation methods here at specific points if you have a need to do that for some reason. So that allows you to set that up. So, all right. So once we've got that all set up here, I want to just kind of quickly run an analysis, and we'll take a look at some of the outputs and stuff. And I know we're kind of coming up to the end of the meeting time here, but I want to make sure we kind of go over output real quick here.
Yeah, while Carolyn's doing this, the output is going to be similar. If you were here the other day when we were talking about other types of output, there's a specification viewer, so it's going to run through and do specification checks at the points of interest along the top slab, the walls, and the bottom slab. So you'll be able to sort through those by element type. There is also a detailed report and a summary report that you can review as well. It's a little bit different than some of the other BrR output. This program, the Culvert Reinforced Concrete Culvert program, we inherited from the Wisconsin DOT to implement into BrR, so it does have a little bit different look than some of the other BrR output. So, go ahead, Carolyn.
Oh, yes, exactly. Thank you. Yeah, exactly like Mark said. We do have some of the things here that you'll see with, your sort of other structure types that controlling rating factors and components and locations here in the tabular results. And then similarly in the spec check detail, like we have with other structure types, you've got your different rating articles and equations and stuff here, so you can go through and look at what it's doing. In terms of the additional reporting, like Mark had just mentioned, this is one of those structure types, culverts and trusses particularly. You'll want to look at these engine output reports as well. So here for engine output, so this is the alternative and segment that we just analyzed. So we have a summary output and a detailed output. The summary output report covers, basically summarizes a lot of the input that we entered as we were going through here, as far as like the culvert geometry and properties and stuff, reinforcement details. And then this also shows basically the process that's kind of happening as that finite element model gets generated. So if you're looking at like specific points along the structure and you want to look at what's happening at a certain point, this references like the nodes that are used in the finite element model for the different walls and for the different elements and stuff here. So we've got the nodes and then the supports and fixity and stuff here as well too. So this is kind of some information about how the finite element model is set up. Scrolling through here, we also have information about the different loads and stuff that are entered, and then showing, those loads get applied to the different, components, and then the forces that are generated from there. So, if you ever want to cross-check it against anything, or see some more information about where those forces and stuff are coming from and how they're generated, you can see there's quite a bit of information here with that finite element model. Let's see, again, then here we also have, again, the spec check articles and stuff that are computed, controlling ratings. So quite a bit of information here. Again, this one is set up a little bit differently, like Mark mentioned. The Culvert engine is a little bit different in terms of the output that's available. But we do want to just make sure that just mention that this is here, just since this is different for some of the structure types, and people may not know that it's there. So again, you can access that here through this engine outputs, and then the summary and detail reports. Okay. With that being said, I know we're kind of coming up to the
Maybe real quick, Carolyn, go over the open up the spec check detail window. And so this is the part that is a little bit similar to the girder. So a lot of that stuff that's in the output file, we have organized here in a spec check detail. So you could do the same type of thing where you can search through and look at specific specification checks, especially if you have something that fails, you can come in here and find the location that fails and look at the details related to it.
Yes, exactly. Yeah, thank you, Mark. Yeah, so this information is here, and we do. This is definitely, like we said, if you check, your tabular results, if something fails, this is probably the place to start as far as looking at it. We do want to just make sure that there is some additional information available here too in the engine outputs. But yes, this is, I think, the place to start when you're kind of trying to look at what's working and what's not. So yeah, thank you. All right. So I think that kind of covers, I think, what we had wanted to go over here today. I know we said if we had a little time, we could talk about the soil structure interaction. It is going to be a little while still before that's fully available in the software. But like we said, just to recap, what we have now for corrugated metal pipe is the empirical analysis. For reinforced concrete box culvert is the finite element modeling that follows the process that we just talked about. And then we'll have more advanced soil structure interaction analysis a few versions down the road. So with that being said, I think that covers everything that we were going to cover here. Were there any questions or anything?
Yeah, and we can hang on for a little bit. We are at our time, but we'd be more than happy to hang on if there are any questions. And Sean, if you want, I could do a quick thing on the soil structure interaction, but let's see if there's any questions first.
I'll chime in quick if anyone has any questions. So raise your hands or put in the comments. Just a couple of things I want to bring up in case people need to get going. I said this in the last training, but for anyone who wasn't at that last one, just a reminder for bridge ID and the structure MBI, they both need to be unique for every bridge. So
Yes.
a lot of the counties have similar bridge ID numbers. So we recommend either putting the FHWA number for both those values, or if you really want your bridge ID in there, consider making it a little more unique by adding the county or the city or something in there, just so we don't get duplicates of those. And the other thing I want to let you guys know is, along with the example of the CMP, we also have an example of a triple box culvert, one of our standards, that you can also find in that template folder. So if you want to see how one of our standards have been modeled into BrR, you can go there. We have a triple box right now, and we're hoping to get a twin and a single box in there by the end of this project. So thank you.
Thank you, John.
Sean, do you want me to go over the SSI stuff or
Uh, if
anybody? Yeah, go ahead.
if you want to do like a quick talk about that, if people need to jump off, we understand, but we can quick get that so we at least have a recorded discussion on
Okay.
it that people can go back to.
Okay. Let me just share my screen. Okay. Oops, let me do share a different screen. Okay. Can everybody see the screen all right?
Yes.
Okay. So coming in future versions of BRR, if you all are familiar with Candy, if you're not, Candy is a an analysis program that will do not only the analysis of the structure, but will model the soil uh, with the structure as well. So we call it soil structure interaction. So the soil is modeled, and for design purposes, culvert manufacturers use this because they put different backfill, particularly on corrugated metal pipes, where it has an effect as it's being backfilled. And so Candy allows for the modeling in different stages. So it's a nonlinear analysis. So as the analysis is being done, results are saved from previous stages, and the deflection of the culvert is taken into taken into account as it's being loaded. What we're doing with BRR, Candy is an older program. The last time user interface was updated was an NCHRP project that I worked on about 20 years ago. And so it's still out there, it's still available for your use. Initially, it was primarily used for design. There was a modification made a few years ago to allow you to do rating with something called the Candy Toolbox. And it was developed during a research project that I worked on where we were looking at changing the specifications for some of the culverts. So currently we are working on converting, not really converting, but reprogramming the elements that are used in Candy, particularly the soil elements, um, and putting them into the BRR finite element model. The 7.8 version of the software, which will come out next year, will have that engine in it, but it will not directly be available to the users. So the first phase is to actually get the engine to work, and we will be validating it by comparing it to the Candy, the current Candy software. Uh, Beyond that, phase two, we'll start to be able to input models for reinforced concrete box culverts and for corrugated metal pipes, since there are a lot of states that have input reinforcement for box culverts already. We're going to make use of that when we build the Candy model. So essentially, you'll be able to analyze the reinforced concrete box culverts the way you do right now with a simplified method that Carolyn just went over. And then there'll be an option to do it with the soil structure interaction as well. Um, since the corrugated metal pipe definitions are empirical and the definitions are simple right now, there'll be some additional input you'll have to provide for corrugated metal pipes, but it will take into account um, the backfill process that's very important to the corrugated metal pipes. Phase two will also include a live load analysis and some of the graphical output that you see in the Candy software. And then finally, stage three, which is another year later, will look at introducing more complicated models like this one, where you have three pipes together, and the results of the model are dependent on the three being together and modeling them at the same time. And we'll also be considering multiple materials and different methods for improving the live load analysis. So that's kind of it in a nutshell. I just wanted to let you know that that's coming. Carolyn mentioned that the corrugated metal pipe is an empirical solution right now. We're trying to move towards a more accurate solution for those structures in particular, but also for the reinforced concrete structures. So if anybody has any questions on that, you could certainly ask them now, or forward them to us later. And that's, Sean, that was all I had. I just wanted to give a brief update.
Great. Thank you. So if people need to jump off, you can start jumping off. But if people still want any questions, I'll stick around for a little bit longer. But thanks everybody for coming.
Thank you all.
Yes, thank you.
Hello, can you hear me?
Yes.
I wanted to ask about the CMPs, the seam strength actually in the properties.
That, you mean, is the seam strength one of the properties?
Yeah, I just wanted to ask what it would like represent. I had a semicircular CMP.
Mm-hmm.
Mostly it was under a railroad bridge, which in hindsight doesn't seem like a good idea. But it didn't have any seam strength, and it was a correlated pipe. Like so, what would the seam strength actually represent?
Hold on a second. Trying to see if I can find something that might be able to illustrate. Sorry, just give me 1 second here. Sorry, I'm looking for a reference here. I know I've got it here somewhere, and I am not finding it at the moment. Um, yeah, I'm sorry. I'm looking for a reference here. That I know I've got it here somewhere, and I'm not finding it. As far as the structure that you mentioned, were you saying that seam strength controlled for that situation, or that seam strength wasn't applicable, like that concrete it just wasn't applicable for that?
Well, without the seam strength, I couldn't run the model, and I didn't have anything for seam strength. Like it was not kind of applicable.
Oh, okay, I see. And you said that was you said that it was like a corrugated arch though, right? Not-
Yes, it was
Okay.
a smooth steel pipe, but not a complete, but half of it. Like,
Okay,
I don't
so
know if
yeah,
I'm
so
making
that
any
is a little
sense.
bit different then. If it is just like a plate arch, I think that is just kind of a little bit of a different type of culvert as opposed to the corrugated metal pipe. And I think that this like kind of as far as what we were saying about sorry, I'm looking for an example here while we're talking, but as far as
Well,
what we were saying about the empirical process, I'm trying to pull up one of
yeah,
the plate arch ones.
yeah, and I was just looking in I was looking in the method of solution manual, and we do have in the flow chart that if it's a spiral rib pipe, we take into account seam strength with the seam capacity. And this is just from the flow chart and the method of solution the Methodist solution manual. So I guess you're saying you did not enter the seam strength?
Well, you couldn't model it without, you couldn't rate it without entering the seam strength. I did use this. I think I saw it in your not over here, but I saw this in Astro LRFT or somewhere, the 5 the equation that you was showing. But
Yeah, this
it was,
looks like it's 12723. At least what's labeled here. Uh,
and it also seemed like seam strength was the controlling property.
okay.
That's why I just wanted to ask, what would like seam strength be in most pipes?
Well, I think if you have a structure type where, I mean, I think if you have a structure type where it's applicable, I think you normally would be able to get it from the structure plans. But the one thing I just wanted to mention here too, so on the culvert alternatives, when you, like the ones that we were showing were like the corrugated metal pipe, but when you go to culvert alternative, there's like metal pipe, comma, arch, comma, pipe arch, and then there's another option for metal box. Um, Within the metal pipe arch, in that culvert alternative description, there's a drop down for structure type that has corrugated metal pipe, spiral rib pipe, or structural plate pipe. And so it may be that I mean, it's hard to say without exactly seeing the model or the structure that you're talking about, but it may be that you would need to change the structure type in that culvert alternative description if it's a structure that seam strength just isn't applicable for that structure type. Um, it may be that you would just need to change the structure types that's set in that alternative, so that it wouldn't be checking something that may not be applicable for that culvert, if that makes sense.
Yeah, and if you would, if you want, you could send your culvert and your question to BRDR at promiles.com. That'll go to our support board, and we could take a closer look at it. Because maybe there's something there that we're not seeing through the or understanding through the conversation. So export your file, send it to that email, and just put a quick description of, what is, I didn't enter seam strength. What is it used for? Why is it required for this culvert or something like that? Just summarize your question, and then we'll try to answer it through the normal support process.
Okay.
Usually we get back to you within a day.
Yeah, okay, I can do that. But I did try the other way. That I think I tried. I don't remember. It's been a while, but I tried changing the alternatives to
Okay.
corrugated from corrugated metal pipes to spiral rib or structure. I think it still required the seam strength kind of part, but I'll
Okay.
export it
And
and
if
send it
that
to
if
you.
that yeah, and if that's the case, somebody that worked on the corrugated metal pipe could look at it and say, "Oh, that's because blah blah blah." you
Yeah.
know, it might be a little easier for us to answer if we could look at the example specifically, and we'll try to get back to you right away on that.
Yep.
Yeah.
Okay. Thank you.
Thanks for the question.
Yes, thank you.